Yes, I'm in the ham radio thing. It's okay.
Okay, so we did one question so far. Let's do another one.
Sounds good.
We'll talk more about Ohm's law.
Mm-hmm.
So we define the ohm, or unit of resistance, is the technical definition. It's the resistance between 2 points of a conductor when a constant potential difference of 1 volt is applied to those points, produces in the conductor a current of 1 ampere, the conductor not being the seat of any electromotive force. That means no outside electric field. So that's the technical definition.
Mm-hmm.
Basically, Ohm's law is the ratio of voltage to current.
Mm-hmm.
And Mr. Ohm determined that by actually measuring materials, applying a voltage and measuring the current, and plotting. And he found out that they all presented a straight line, the slope of the line being the amount of resistance for that material. And like I said, we use that Greek symbol omega a lot of times. It's not on your keyboard, so it's hard to do when you...
Mm-hmm.
This is just kind of an example of what he actually did by plotting, taking a material and applying different voltages and plotting the current. And you will get a straight line. Maybe a little zigzag due to measurement error, but basically a straight line. And that slope is R. So if you're familiar with algebra, you probably learned the formula for essentially a straight line, where y is equal to mx plus b,
Mm-hmm.
b being the y-intercept. In this case, it's going to be 0.
Mm-hmm.
So it's just y equals x, or m would be R, and I would be current, and Y would be E, the voltage. So to help people remember it, they came up with this little pie chart where, and if it helps, this is one of the things you can draw on the back of your answer sheet. Just draw this little circle, divide it in half, and then divide half of that in half. And you put E at the top, and I and R. So in order to remember the formula, if you want to find voltage, you'd put your finger over the E, and it says that the voltage then would be the current times the resistance. If you wanted to find current, you put your finger there, and it's going to be the voltage divided by resistance.
Mm-hmm.
And likewise, if you want to find R, it's going to be the voltage divided by the current. So it's just an easy way to remember it if you can't remember the formulas, or if you're not good at algebra.
I find that formula is pretty easy.
Okay.
In the math. The Ohm's law.
Yeah, Ohm's law is basically E is equal to I times R. And if you go rearrange, you can get I is equal to E over R, or R is equal to E over I. There's just some examples with numbers.
A few?
So, what formula is used to calculate voltage in a circuit?
Oh, wait. Which formula calculate voltage? E equals I times R. Alpha.
Okay. What formula is used to calculate resistance?
Equals A
Divided by
B.
Bravo.
So why don't we just do that and then we'll read there, have some lunch.
E over I.
So let's
E
11.
over I. Bravo.
Bravo. What formula is used to calculate current?
RA,
Bravo.
alpha.
Bravo.
Bravo.
I heard two bravos.
Oh, I'm thinking of a different formula. I equals current equals E B. I wouldn't mind taking it now.
So here's some example problems. What is the resistance of a circuit in which a current of 4 amperes flows when connected to 120 volts? So we know voltage and we know current.
Gotcha. 120 divided by 4, yeah.
So we divide the voltage by the current, right? And we get 30 ohms.
Mm-hmm.
So what's the resistance if we have 12 volts and 2 amperes of current? 12 volts divided by 2 amperes.
That's 6.
And the third one, we have 3 amperes from a, things in the way, 12 volt source.
12 divided by
So it's
3.
going to be 12 divided by 3.
I
Any
just want you
questions
to
on
know that
those?
I slowed down right here. that we translate this into actual application, and I'm going, so just want to say.
That's where I get lost too. But I find that the formula I get it, but applying it, I'm not sure exactly where and when I'll do that, but maybe we don't have to worry about that right now.
Well, there'll be some actual questions like these. That's why I'm showing examples.
Oh yeah, what I think what I heard is, and what I feel too is like the formula, I get it, but applying the formula in real life on the radio and testing it and everything like that with the correct devices, that's where I wouldn't know actually how to apply it in real life, but I know how to do I know how to do the math. I've always felt that way about math. Usually, I know how to do the formulas, but not know when and where to use them. But
Well,
we're
that's
being
what we're
tested on
gonna do.
math.
We're going to learn how to apply it.
Oh,
Yes,
perfect.
this is going a little faster than I would like. If we spend a
Okay.
little more time, I could become better at it.
Okay. So
Or
let's
maybe I'll
try.
just go back and do them because they'll be in the slides, right? So that's good. If they're in the slides, I'll go back later and do them. Just
Yeah.
wanted you to know.
Okay. You want to go over these again?
Just give me a minute to kind of process it all.
Okay.
Is 2 amps. So what is R? E is 12 divided by 2 equals R equals 6 ohm.
I can put it in you.
One of the things that takes a while to sort of become, I don't know, proficient with is the formula versus the units. not versus, but the formula, and then the units. You follow me?
Yeah. Well, you missed the first section where we talked more about the units
I
of
didn't.
volts and
This is
amps.
Pat. This is Pat, and I didn't miss it. I
Oh,
was
okay.
here for it. It's just not familiar. So I just need practice is really what I need.
Yeah,
So,
well, it just takes a little
so I'm getting.
practice.
So I got these. If everyone else wants to go ahead, we can go to the next one.
Okay.
Thank
So
you.
now we'll do current. Okay, so if we have 120 volts and a resistance of 60 ohms, how much current would be flowing? So if you look at the little pie chart again, or the formula for current, it's going to be the voltage divided by the resistance. And we know the voltage, they told us in the question, and we know the resistance. So we just plug those numbers in the formula, 120 for E and 60 for R. And this simple math, 2 amperes. If we have 200 ohms and 200 volts, we plug 200 and 200 into the formula, and we get 1 ampere. And if we had 24 ohms and 120 volts, it's going to come out to 5 amperes. It's just have to remember you divide the voltage by the resistance to get the current. The higher the resistance, the lower the current is going to be. And conversely, the higher the voltage, the higher the current's going to be for a given resistance. Everybody clear on those?
Yes.
Sure.
Okay, so we'll do voltage now. So if we've got a 10 ohm resistor and the current is half an ampere, what would be the voltage across that resistor? So it's the basic Ohm's law formula, E is equal to I times R.
Mm-hmm.
So we know the current of half an amp, and we know the resistance, it's 10 ohms. So if you multiply it out, you get half a volt. If we had a 10 ohm resistor and 1.5 amperes, okay, we're going to get 15 volts because the current is 1.5 times what it was, or 3 times what it was in the previous example. So the voltage is 3 times as high. And if we go with a 50 ohm resistor and the current is 2 amps, it would take 100 volts to create that amount of current through that 50 ohm resistor. Everybody comfortable with those?
Getting there.
Yes, I am.
Well, let's try a real one. So we have a current of 3 amps and we have a voltage of 90 volts. Looks like my font changed a little bit there. What is the resistance?
Bravo.
Formula, R would be equal to voltage divided by
That's Bravo.
the current, right?
I know that some folks are still working on this. I have a question. Next week I won't be able to make it. Do you have a way to send out the recording next week so I can do this class on my own during the week next week?
Oh yeah.
Perfect.
I'll send you the link. I put them on my YouTube site.
Great.
So there's a lot of previous ones on there too.
Awesome.
And I put copies of the slides on my Dropbox account. I'll send you the link to that too.
Thank you very much. That sounds great.
Perfect.
Do you want them in PDF or open document?
PDF is good.
Okay. Because I don't do
You're sending
PowerPoint.
Are you sending out the slides? Is that what you said?
I'll send a link to my Dropbox and they'll be on the Dropbox.
Excellent. Excellent. That's good.
Do we have to have Dropbox to get Dropbox?
No,
Okay.
you just have to follow the link.
Okay.
Okay, so what's the consensus here? Alpha, Bravo, Charlie, Delta?
Bravo.
I heard a Bravo.
It's in the chat box too.
Bravo.
Well, let's see. It's Bravo. 90 volts divided by 3 amperes. What's the resistance of a circuit for which the applied voltage is 12 volts and the current flow is 1.5 amperes?
Okay, you're gonna make me use a calculator.
You can estimate it in your head.
Okay.
See, if it was 12 volts and the current was 1 amp, it would be 12 ohms, right? If it was 12 volts and the current was 2 amps, it'd be 6. So at 1.5, it must be somewhere in the middle.
Yep.
Charlie.
Mm-hmm.
What is the resistance of a circuit that draws 4 amperes from a 12 volt source?
Alpha.
Alpha.
I'm just curious how the chats look.
I'm okay with alpha.
What is the current in a circuit when an applied voltage of 120 volts and a resistance of 80 ohms? These are all just like the examples I showed, except slightly different numbers. So current is equal to voltage divided by resistance, right?
Mm-hmm.
So would be 120 over 80.
Mm-hmm. Reduce, reduce, reduce. Delta.
Delta. What's the current through a 100 ohm resistor when connected across 200 volts? That should be an easy one.
Mm-hmm.
Charlie.
Sure.
Charlie. What's the current through a 24 ohm resistor when connected across 240 volts?
Oh, Chucky, baby.
Another Charlie. What is the voltage across a 2 ohm resistor if a current of half an amp flows through it? That one sounds familiar.
What is that? Oh.
Remember, voltage is going to be the current times the resistance.
Oh, alpha.
I heard an alpha.
Mm-hmm.
Alpha.
Let's see. Alpha. What is the voltage across a 10 ohm resistor if a current of 1 ampere flows through it? So it's old I times R.
Mm-hmm. Anything times one is anything. Bravo. Yep.
What is the voltage across a 10 ohm resistor if a current of 2 amperes flows through it?
Mm-hmm.
Yeah, delta.
Yep, delta. Okay. That's all of those. Now we'll talk a little bit about series and parallel components. Because when we put resistors in series or in parallel, we have to figure out what the equivalent resistance is. So if we have two resistors in series, the equivalent resistance is going to be the value of the two resistors added together.
Can I ask a clarifying question? Because I know when I did the training videos, it didn't actually go through the individual symbols. When you say resistor, are those spiked lines? Is that what the resistor is? Like the symbols, I actually don't know the symbols. I've been looking for it, like researching them and looking at them up, but they weren't actually in the training specific. Yeah.
Those are the 5 ohms.
Well, in this diagram, the
Mhm.
resistor is that symbol with the up and down. It looks like mountains. Is that what a resistor is?
Correct.
Is great.
And
Okay, great.
and we'll do circuit diagrams and those symbols a little bit later.
Perfect. I'm good then.
Okay.
That helps. Yeah, that's actually one of the places I have the most difficulty.
Okay. So if they're in series, we add them together, and the voltage across each of the resistors may be different if they're different values, because they'll have the same current that flows through both of them. Okay, so you would do the voltage across R1 by multiplying it times the current, and the voltage across R2 multiplying it by the current. And those two voltages add up to whatever the supply voltage is. So if we have 10 volts, like in that circuit, and those two, I believe, mine are covered up.
They're equal, right? 5 volts each.
They're both equal, so they're 5 volts. So it has to add up to the supply voltage. There's a thing called Kirchhoff's voltage law, which says the voltages around a circuit must add up to 0. We have 10 volts coming up, and then we have an opposing 10 volts in the opposite direction, so they cancel out. So it's 0 around the circuit. Okay.
So when I'm looking at this diagram and it says R1 and R2, so I'm looking at the formula, I is current times R1. R1, what does R1 stand for?
That resistor R1.
So that's just name, and that would be the equivalent of 5 ohms.
It's equal to 5 ohms, right?
Mm-hmm.
And R2, another
reading this right, and so E2, R2
they're both
is also 5 ohms. And
they're both 5 ohms.
I just want to see if I'm reading this right. So the I current, if on the top of the diagram, it looks like a rectangle. The I current with the arrow going to the right over that circle with the A, where it says current 1.0, that's the amps, right?
Correct. That symbol is for an amp meter showing the amount of current. If you were to put that in the circuit, and it's showing that the current is the same through both of those resistors.
Okay, and where it says E2, that's voltage 2 going through the resistor 2 at 5 ohms, is that right? And then it travels through the second amp meter at 1.0 amps, then through the resistor 5
Correct.
ohm. Within E2, E1 is voltage 1.
And right, V1 is the voltage from the power supply or the battery.
Okay, and then it goes around, and then where does it go after that? Does it just go around again?
It comes, well, the current flows conventionally from the positive terminal on that power supply back to the negative terminal.
Yeah.
So it just goes around that loop.
Huh?
And it will continue to circulate around that loop as long as that voltage is there.
So the circle that has the plus minus sign, it's coming out on the positive side and it's returning on the negative side. So that's how it cancels out.
Those arrows with the eye on them are showing the way the current is traveling.
But so if you're following it around, the V1 at 10 volts, it's coming out on the positive side, going around, and it comes back up to the negative side. So you got the 10. Okay, I got it.
And
Can I ask a sort of away from the whole thing for a minute and just say, I always expected that resistors cause the voltage to go down.
No, they cause
right.
they cause the current to go down.
They cause the current to go down.
Yeah.
So they reduce the strength of it?
Which is why
Okay.
They provide an opposition to current flow.
Right.
So the higher the value of the resistor, the more opposition there is and less current flow.
So in this case, we're starting out with a potential current voltage of 10 volts, and off it goes through the resistor, two resistors,
right?
and it comes out at 10 volts.
Well, it actually would be 0 at that other end. It starts off at the power supply at 10, which
Well,
the little,
that part makes sense to me, but when I'm looking at these formulas and so on, and I don't see 0 anywhere. So if you've got 10 volts starting out and it goes
well,
down, the current is, so the current is 1 amp because that's just a rule. And we say 1
no,
amp,
the current is 1 amp because those two
right?
resistors add up to 10 ohms. So 10 volts divided by 10 ohms would be 1 amp.
Okay, so looking at the diagram, this is hard to do, but we follow the voltage up.
Challenge here
And
is putting the numbers in.
it's that right. It's a current. So it's a current of 1 amp, and it goes through by the first arrow. That's right, with your cursor, and it goes through the first resistor. And now we have a half amp. Is that
No,
right?
it's still 1 amp.
It's still 1 amp, even though it's been through a resistor of 5
The current
ohms.
This 5
going to be like
plus.
that.
But at this point, in the upper right corner of this, and it's gone only through one resistor.
1 times 5 is 5. That would be 10.
It'd be half an amp.
No,
Boss.
remember,
If you
that-
only had one resistor instead of two,
Oh. Okay,
would it be a half an amp is what arrives at the other end?
no, it would be 2.
Okay. And then it goes to the other one.
You'd have 10 volts divided by 5 ohms. So it's going to be equal to 2 amps.
Okay, but the current keeps going at 10, right?
So the voltage stays at 10.
The voltage stays at.
Well, the input voltage. Right here, where we're measuring it with this voltmeter, is 10 volts. If we were to put a voltmeter across this resistor, we'd measure 5 volts. And if we put one across this resistor, we'd measure 5 volts because they have to add up to this 10 volts.
Well, I have to say that I'm a little mystified by the difference between voltage and current. Seems to me it's just I don't understand why they have different names. I mean, if they're the same thing in the world, what makes them different in the world?
Voltage
Voltage
is
and
the
current.
force that causes current to flow. Okay?
Okay.
The resistance is the opposition to that current flow. So if I have no resistance, doesn't matter what the voltage is, it's going to be an infinite current. We call that a short circuit. If I have a very, very high resistance, I'm going to have a very small current flow, maybe none if it's high enough resistance. So remember, it's the
The current, so just in this example, the current before the resistors happen is has to do with the material that it's flowing through. Say it's a wire. It's the
well, that
resistance that's in the wire.
determines the amount of resistance, the
In the
material.
wire.
Okay. But the key thing in this circuit, because it's series, is the current has to be the same through all of the components. Even if I had 4 resistors in there, it doesn't matter. The current is going to be the same. Now, the current will vary depending upon the amount of resistance. If I keep the voltage the same and change the value of the resistance, it will change the value of the current. But the current will be the same through all of the resistors. That's really the key point for a series circuit.
If you were hearing that with my ears, you would be just baffled. But go on, because I'm just going to have to work this out myself, I think.
Okay.
And it doesn't have to do with the series. It doesn't have to do particularly with the series business. It has to do with.
I just want to. I want to clarify something.
Sure, go ahead.
Okay.
Something. So
Don't
what
say
I'm
it wrong, though.
is current remains. So I want to see if I'm hearing this correctly. So the current remains all of the what I think is a little well, if it's the resistor, it sounded like amps drop. Correct or no?
You're breaking up.
Let's see, maybe so like you can't hear me? Let me
You were breaking up. I could only hear bits and pieces. Yeah, you're okay now.
Oh. Let me try again. So I'm hearing that the amps are consistent through all of the resistors, but when it moves through a resistor, if the amps drop, how can it be consistent drop at the same time? That's what I want to clarify. What am I not understanding there? Great. It sounded like it remains consistent, but it also drops. But if I'm incorrect, I'd love to have some clarity about that.
Okay, the current stays the same.
Current stays the same, even through the resistor as well?
Yes.
Okay, and
because
then
the amount of the resistance, all of them added up together, determines the amount of current.
Oh.
So we have 2 resistors there that add up to 10 ohms. So that causes the current to be 1 ampere.
Okay.
If I change those to, say, 10 ohm resistors, then my current is going to go down to half an ampere.
Oh.
But it's still going to be the same through both resistors.
Okay.
If the resistors are different value, say one is 5 and one is 10, the total would be 15. So the current is going to be 10 divided by 15.
1.5.
But it'd be the same through both of them. Okay. But the voltage drop across each of those resistors is now going to be different, because it would be that current, like 3/4 of an amp, times the 5 ohms and times the 10 ohms. And it would still have to add up to 10 volts.
Okay, I'm going to try and plug in the numbers and see if I can. I think that when I'm looking at the diagram, I don't quite get it. But I'm going to try as you guys are kind of going through this, I'm going to see if I can do the math, and maybe it will make more sense to me when I actually do it. So I'm going to continue to listen. I have the diagram. I wrote it out physically, and I'm going to try and plug in the numbers to see if I can see where maths. I think that would be good. So I'm going to try that while you guys are working.
All right. Because on the next one, we're going to do parallel, so it'll really blow your mind.
Oh, no. Oh, no, we went there already. Actually, could you go back for a moment? Can I take a photograph of that, and I'll do the math later on? Could you just go back to the slide, and I'll take a screenshot?
Okay.
I want to work on that later and see if I can get it. Okay. Thank you. I think I just need to spend some time looking at it and playing with it. Got it.
It just takes practice.
Yeah. I can see that.
Hmm.
Okay, you can go to the next slide.
All right. So a question, which type of circuit is DC current the same through all components?
Oh man.
Alpha.
Alpha series.
Remember, the key point I said for a series circuit was the current is the same through all components.
Mm-hmm. Cool. DC is the same.
Okay, so now we'll talk about parallel.
Okay.
Instead of in series, we have two resistors that are side by side.
Two resist. Okay.
So in this case, there's a thing you don't have to remember. There's a thing called Kirchhoff's current law, which says that the currents at any node have to add up to zero.
Mm-hmm.
So what that means kind of in this one is instead of the current being the same through each of those resistors, the voltage across them is going to be the same. The
Okay.
current will be different.
Oh.
As you can see, there are two different values resistors. There's 10 volts across each resistor. So the current through one is 4 amps and the current through the other is 2 amps. But that 2 amps adds up to 6, which is what we see. I didn't label it, what you would see coming out of the power supply. It's going to supply 4 amps down one leg and 2 amps down the other leg, or 6 total. So the basic difference in a series circuit, the current is the same. In a parallel circuit, the voltage is the same.
Interesting.
It's the law of physics.
It's in the Chinese sense. Interesting. May you live in interesting times.
Okay, so in
Oh.
which type of circuit is the voltage the same across all components?
Parallel. Bravo.
Bravo.
Yep. I mean, for now, the main thing you need to remember is a series circuit, the current is the same. A parallel circuit, the voltage is the same. You don't have to know how to figure the values.
Oh, perfect. Great. I was going to say, I don't know.
Well, that takes a load
We
off my
just have to
mind.
parrot back the definition, eh?
Great.
Right. That will come later.
Okay.
Parrot back the definition, all right.
So we learn Ohm's law with the little pie chart, and that the unit of resistance is ohms. A series circuit is the same current flows through all components, and in a parallel circuit, the voltage is the same across all components.
Yep.
So this was one group, which means on the exam, you will get one of those questions we went through.
Uh-huh.
So you might get the simple one like series circuit. Or you might get one of them where you actually have to plug in numbers.
Mm-hmm.
But you'll only get one.
Gotcha.